This property was bought about a year or so ago. At the time of the purchase, the survey flagged up damp on the rear wall. The recommendation was rising damp proofing treatment, which was undertaken a few months later. The wall remained damp. These were the discussions and findings during the survey.
So the background to this is the property was bought a year or so ago.
Yeah, April 2023.
And you, as part of the purchase, you had a local damp proofing company come and quote for work.
Yes.
And they then came back in November, was it?
That's when they did the initial work.
They did the initial work in November.
Yes.
That didn't include the damp proofing drilling on the outside.
Correct.
But what did it involve? Just replacing the plaster?
Replacing plaster. They also injected the wall.
From the inside?
From the inside,
okay.
Mud and then plaster, and on the outside the
And so wood as in?
Mud.
Oh, mud.
Oh,
okay, yeah, well, okay. Damp proofers.
Yeah.
Slurry.
Slurry, exactly. And then a plinth on the outside.
Yeah, they cut the decking because they thought...
And they said they'd cut the decking backwards,
and
but they only cut it by millimetres, basically.
They cut the decking to allow a bit more airflow.
To expose the... because before the decking came all the way up to the edge, so they exposed the vent
in order
to get the air. Yeah, well, that is something that we're going to look at and understand. And they
also did it. They cut back a little bit here as well.
But the damp proofers slurry didn't dry off.
It dried, and then the same shape that was there before reappeared.
Yes.
Okay. Oh, so it dried completely and then reappeared later?
I think basically as it was drying, the shape was still there.
And then eventually...
and then it started
exactly
rising.
Mirroring the original shape.
Yeah, but then it gradually became what looked to me, it might have been because it was fresh plaster or whatever, but it looked worse. It spread out even more than you could see when it was in white paint.
And then this... You were asked to then draw a line, and that's in December, was it?
That was in January.
January.
And then I further sent them, they said draw a line and wait a couple of weeks.
Yeah.
So then it went past the line.
It grew.
It grew past the line.
Past the line.
And I contacted them again, and then they said, well, we'll need to bring up the floors, and that will cost you $4,500.
Okay. And at that point you thought you needed independent advice?
Yes.
Okay, good. So this is the damp meter, and you can use it in lots of different ways, but looking for a number, so for example 95 or anything over 95 or 100% is useful. So you want to make sure it's on masonry mode, and you have to flick it up and down to do that. You can also put it on surface work mode, and here that's building, and in this case it's used like a standard damp meter.
Right. Typically
above 30% is, or 25% is considered damp. With the, as I say, it's qualitative, so you're looking for changes over time rather than necessarily high meter. You'll find that a standard wall will be about 50% with this, and it's just a number. Don't worry about what it means. You can think of it as saturation, but that doesn't necessarily help. What it's doing is it's sending radio waves into the wall and bouncing back. And 50% is not bouncing back compared to 100% that is bouncing back. So it's not the thing you've got to remember here is that you've got two risks. You've got, in addition to the things I said earlier, you've got metal in the wall here, and that metal is going to take out a section of plaster, and the metal itself is going to become cold, so you're going to have a risk of condensation around here, and you can see some of the dampness is around there. So it's always going to be worse around a socket. There's not a lot you can do about that other than deal with the condensation, which is going to be the cause of that. And also at the base of the wall, because condensation will drop down through gravity. But also you've got the subfloor ventilation is here, just under the floor, and it's going to create a bit of a cold zone there. So you're always going to have a little bit more of an increase here. The corner, that's less common with terrace properties. You get it to more in semi-detached. But I'll go and have a look at the neighbour and see if I can see anything there.
Provide you a dehumidifier, and then when the guy did the outside drilling, he was like, "Oh, you don't need a dehumidifier," and then his manager ended up sending one anyway.
So the thing you have to be aware of is that this was an internal conservatory.
Yes.
And somebody has applied a coating to it. We don't know what the coating is, but there's a good chance that this coating is impermeable. That means that it doesn't allow water to be absorbed in, but equally it doesn't allow it to evaporate out.
Okay.
And yet, as you come down the wall, you'll see that this area here is a different material. It doesn't have the same coating on it. It has paint, and I'm going to guess that paint is semi-permeable.
Right.
It's weather shield, I think it's called. They're the most commonly used for paint or Dulux. And so there could be a lot of things happening, and I'm going to say that condensation is probably part of the problem, but I think the other part of the problem is the absorption difference from the outside, caused by a difference in material. That one is allowing absorption, the other one's not. And what will happen is water will stream down the wall because it's not being absorbed by this coat, and it hits this area and it becomes more vulnerable, and that creates an increase in the amount of water. You know, if it was all the same material, then you'll get even absorption, but because there's a difference in material, you get an increase in absorption. But I think it's working together with the condensation on the inside. You say that it's worse when you cook, when there's a lot of cooking, and the ventilation in the kitchen is not extracting out, it's recirculating, so none of the vapour is being removed.
Right.
But we'll have a look at the data loggers, that will help.
Yes.
And I'm going to give you a lot of recommendations and methods of monitoring it. And that should solve the problem, but there is one caveat, that you might have an issue in the subfloor void. So I need to find a way of measuring the subfloor humidity.
Right.
Because if you do have a problem there, then you've got risk of rot, which is obviously another issue.
Okay.
I'm not a big believer in damp proofing treatment, primarily because it's not diagnosing the source of damp. It's treating everything any damp at the ground level as coming from groundwater, which in London it just wouldn't be, because it's pumped out and you don't have a risk. You can have a look on the. I'll look on the land underneath your building to see if there's a risk, but I don't think you're even in a zone where you have a risk of groundwater, even if it wasn't pumped up. But anyway, setting that aside, there are two things that damp proofing does. Is one, it reduces the natural absorption of vapour, increasing the risk of condensation and mould, because so this normal surface will absorb vapour and it will buffer vapour. But when you put what is essentially, or they call it a slurry, but impermeable surface, they're putting impermeable because they're trying to block the water rather than deal with it. But it will reduce the absorption, but it also the thermal properties aren't as good as normal plaster, so again it increases the risk of condensation because it creates a cold zone. But as I say, you've got a combination of factors here. We'll have a look again at those.
This is the infrared camera highlighting heat loss at the base of the wall. This is common and increases the risk of condensation. So sometimes dampness from the outside can merely penetrate into the first course of bricks, causing damp bricks which lose heat, especially during winter.
So just to explain, I tend to get involved in more complex cases because, well, obviously I charge money. And this one comes from what's called, well, it's calcium nitrate, which is a hygroscopic salt, and it comes from chimney breasts, and it's the burning of fossil fuel, or coal specifically, that causes it. You don't necessarily need to do anything about it. It's not going to go away. You can cover it. Zinsser will do it, and I'll explain that. But at the same time, you know, if you know what it is, you don't have to worry about it. If it was just stranded condensation, it'd be on this wall.
I can see a bit of shape.
Yeah, but then that's would be the chimney breast there as well.
Okay, okay.
But you would expect to see it over here. If it was just condensation, it would be more evenly distributed. This is terrace property, so when they remove chimney breasts, the insulation is often not as good as the original, so you can tend to get more issue. But then that would be on the outside wall only, and not on the outside and the inside.
So as you said, the salt has been left behind by what would have been the interior of the chimney.
Yes.
Yeah, and you wouldn't. And it's not something that can be cleaned off or anything, or.
No, you can cover it, but it's embedded in the.
It's embedded
in the bricks.
Okay.
So.
Right.
And it's not causing any problem. It's not going to cause mold. It's not going to cause rot. It's not a source of moisture. It's if you like, it's a form of condensation, but it's in dynamic equilibrium. That's to say that it's evaporating out as much as it's condensing in. So you'll find that when the humidity goes above 50% relative humidity, so if you're having a shower, it'll start to look a lot worse. It'll start to look quite angry.
Yeah.
I don't know if that's
your
experience.
Yeah.
Yes.
And it doesn't matter what time of year. You'll get it every time of year.
Okay.
I'll show you a couple of things you can do to cover it, but Zinsser's the easiest thing. You can put insulation on, as the other one.
Okay.
But it's only covering it. It's not dealing with it.
Okay.
You'll find a lot of damp proofers accuse this as being an example of groundwater causing rising damp, because groundwater contains hygroscopic salts, but actually this is on the first floor, so clearly it's not going to come from groundwater. And by and large, it comes from chimney breasts. It can come from manure from equine urine. You can find it around old barn conversions and that sort of thing.
Interesting.
Police horses. So in this example, the buyers of a property had it surveyed. There was damp discovered to the rear of the property. The recommendation was to have rising damp proofing treatment, which they did. The damp unfortunately didn't disappear, so they called me up. What we found was that there had been a conservatory to the rear. There was inconsistent paintwork. Some of the paint was more absorbent than other sections of paint. There was also insufficient internal ventilation. For instance, the kitchen had no ventilation at all.